Here are 5 different meters that measure voltage. They report different voltages in different applications, but I consider them all to be accurate voltmeters. This voltmeter is a very low impedance battery tester, testing one defective unused battery and one half-used battery. The defective battery tests bad. Later, with another meter, it will test good. The half-used battery tests good. With the high impedance meter, the defective battery reads 9.2 volts, and the half-used battery reads 9 volts. So the defective battery has high internal resistance, and the voltage drops when a load is placed in series with it. When we place the same load on the half-used battery, the voltage drop is much less. In this case, low impedance is good for diagnosis. We measure the same defective battery on a meter with low but not very low impedance. We have lower volt readings. This meter will read DC voltage on the AC volt scale, which is unusual and useful sometimes. The oscilloscope measures voltage graphically and peak to peak. It has high impedance and causes less voltage drop. 2 other meters on the table display graphically, but it didn't show well on the camera. To show the effect of impedance, I probed both sides of the 1 million ohm resistor. The current load from the meter causes a voltage drop across the resistor. Notice the change in amplitude on the display. We will test the same signal with a high impedance multimeter. The voltage is displayed numerically, and it is RMS, or root mean square, or the approximately DC equivalent, not peak to peak. Notice the change from 2.5 volts to 2 volts, or a 0.5 volt drop. The signal is 2000 hertz. Square wave. Here's another multimeter with pretty good impedance. The graphic display doesn't show on the video. The meter will display plus and minus voltage graphically and also numerically. You can add to get peak to peak. The voltage drop is more significant because of lower impedance. This automotive circuit probe has a voltmeter as well. It displays graphically and numerically, and samples and triggers automatically, which is good sometimes. It correctly shows frequency of the signal. It's not designed for probing sensor circuits, but is handy for probing power circuits. The ability to check pulse DC in circuits that won't be affected by the load caused by the probe has a place in diagnosis. If you have a circuit that has unexpected resistance, a high impedance meter can fool you. You will read voltage that is useless under load. Just don't use it on low power, high speed sensor circuits. I could not read the signal on the far side of the resistor. The voltage drop was too great due to the lower impedance of the tester. I increased the amplitude or voltage of the signal generator. With an 8-volt drop, I could detect a signal of 0.1 volt on the probe.